I remember the moment when it became clear the problem was not armor, not firepower, and not even the number of soldiers, but the gap between command decisions and ground reality that grew each day of war and began to cost time, resources, and people. Back then, nobody spoke about a specific vehicle or solution, yet it was already obvious that units were losing the ability to move fast past information and react to changing conditions without delays that in combat were measured not in minutes but in lives. The US Army entered the war with well-trained soldiers, but with logistics built for peacetime where routes were predictable, roads existed, and communication did not depend on whether you could physically reach the next position. The first months showed that standard transport solutions could not match the pace of modern war. When units shifted, daily officers needed mobility, and the link between headquarters and the front kept breaking because of terrain, weather, and enemy fire. At that point, the problem stopped being abstract and became practical because every delay in delivering an order or evacuating a wounded man began to directly affect the outcome of operations, even when the plan looked perfect on paper. Unlike Germany, which relied on centralized columns and rigid movement structure, or Japan, which often relied on infantry without transport, American units needed a flexible solution between those extremes, but that solution did not exist yet. The start of the war for the United States meant constant time pressure where equipment was developed alongside combat rather than years before it, and every wrong decision showed up not in reports but on roads, shoulders, and temporary command posts. I saw documents where officers stated plainly that they lost contact with units because of radio interference, but because they simply could not physically reach the needed point, especially at night or in bad weather. Pressure increased because war did not wait for tests to end, and any delay between order and execution meant initiative shifted to the enemy regardless of numerical advantage or heavy equipment. In that period, standard cars proved unfit because they required roads, service, and conditions that simply did not exist at the front, especially in North Africa, Italy, and rural European routes. Compared with German staff cars that often stayed tied to rear roads, American commanders more and more faced a choice between speed and safety, without a tool that could combine both. The problem sharpened at night, when limited visibility and unmarked routes made movement nearly impossible, and any navigation error could mean enemy fire or total loss of orientation. That was when it became clear the Army needed not another specialized answer, but a simple, durable, and highly universal platform able to work where roads ended and war began in its most practical form. That realization did not come instantly because at first it was treated as a temporary issue that could be fixed by discipline or more instructions, but combat reality quickly showed the limits of that approach. At that moment, the question stopped being which vehicle is better and became how to survive, move, and decide. When standard rules no longer worked, which became the starting point for what followed. When attempts to solve it with instructions failed, command began to admit the logistic weakness was not in people, but in the lack of a simple tool that let officers and signal teams act regardless of roads, weather, and a stable rear. The consequence was that small units often made decisions late because information arrived after the situation had already changed, and this created a chain of errors that could not be corrected on staff maps. Compared with German approaches that relied on strict columns and preset routes, the US Army faced a more dispersed kind of fighting where fast movement between points often mattered more than formal organization. Pressure grew in rain and on broken dirt tracks when any vehicle with low mobility simply stopped, leaving people without communication supply and the ability to shift position as the fight developed. Gradually, it became obvious that without a universal means of movement, the Army lost not only operational tempo but initiative, because every delay forced units to act reactively rather than proactively, which was dangerously critical early in the war. The first real turning point came when, instead of complex technical answers, attention shifted to simplicity, accepting that in combat, durability and field repair mattered more than comfort or ideal test range performance. This had direct consequences for soldiers because it became possible to move signal officers, medics, and couriers faster to places where their presence meant not convenience, but survival and continuity of unit control. Against the Japanese pattern where many tasks were done on foot due to limited motorization, the American approach began to form a different logic where tactical mobility became a resource like ammunition or fuel. Even then, pressure stayed high because any new platform had to work without full training, often at night and under fire, where a design mistake could instantly become loss of life. I paid attention to reports that stressed requirements were shaped not by engineers, but by frontline practice that forced removal of anything unnecessary and kept only what helped accomplish tasks. This differed from the British approach that often used several specialized vehicles for different roles, while the United States moved toward a universal platform able to cover roles without major adaptation. The result was shorter time between decision and action, felt most at battalion level where commanders could personally check the situation rather than rely only on delayed radio. Front conditions kept pressing because dust, mud, and cold quickly exposed weak points in any design, and only solutions that survived those trials stayed in service longer than a few weeks. Gradually, it became clear success was not one parameter but balance between mobility, ease of maintenance, and the ability to replace or fix parts quickly without specialized equipment. At this stage, the requirements fully formed, turning from an abstract request into a clear understanding that the Army needed a tool that worked always, even when everything else had stopped working. Against this backdrop, the Army request stopped being theoretical and took a concrete shape because it became clear a light four-wheel drive vehicle was needed that could move where maps lost, meaning and decisions had to be made without confirmed routes. The consequence of that approach was a shorter gap between defining the need and building a real prototype, because the Army could not afford years of development when every month meant losses due to lack of tactical mobility, compared with German light staff cars that worked well on roads but lost effectiveness off them. The American requirement assumed from the start that roads might simply not exist. Pressure increased because the new vehicle had to be used at night, in rain, and in low light, when the driver relied not on instruments but on terrain and experience, which raised the cost of any mistake. I studied internal papers that stated clearly the vehicle must not require special training because drivers were often soldiers with minimal experience, and time for training in combat simply did not exist. This had direct consequences for design because complex solutions were filtered out in favor of simple mechanical units that could be understood and repaired without special tools or factory conditions. Unlike the Japanese approach, where much mobility was offset by the endurance of troops, the US Army chose to preserve human strength by moving part of the burden onto machines. Conditions stayed harsh because shortages of steel, rubber, and time meant every extra element increased risk of production delays, which was unacceptable in a global war. Gradually, the requirements became not only tactical but industrial, because the vehicle had to be built by the thousands without loss of quality, with minimal reliance on scarce materials and complex processes. This approach had a practical consequence of lowering unit costs, which allowed the Army to use the vehicle hard rather than treat it as a rare, resource-accepting ware as part of combat reality, compared with British practice, where some vehicles stayed longer in the rear due to limited spare parts. The American logic assumed quick replacement or repair without pulling a unit out of battle. Front pressure showed up in small things, when a bad starter or a broken mount could ruin the delivery of an order or evacuation of a wounded man at night under fire. I noted feedback from officers who said the new type of vehicle was seen not as transport, but as part of the command system without which modern combat became slow and chaotic. This changed the logic of use because the vehicle stopped being a support item and became a tool that directly determined the effectiveness of command and unit coordination. At that moment, the Army request fully solidified into a clear concept that later took material form as a vehicle able to operate at the edge of human and machine limits at the same time. Once the concept was set, I see how the US Army turned it into a strict technical requirement where priority went to weight, drivetrain simplicity, and the ability to keep moving in environments that destroyed standard automotive solutions. The practical consequence was that design ran in parallel with production planning, and each engineering choice was checked not only on a test ground but for mass production without stopping the line. Unlike German practice, where changes often required reworking production lines, the American approach protected a stable base platform with minimal changes to keep output steady even during combat losses. Time pressure was constant because the vehicle was developed while the front already needed it now, and every delay meant added risk for units forced to operate without proper mobile support. I record that key components were deliberately made more rugged than civilian standards demanded because where in mud, sand, and water was inevitable in service, life had to be defined by combat conditions, not ideal ones. This directly affected soldiers because they received equipment that forgave rough use and can keep moving even after partial damage, which reduced mental burden in combat. Compared with Japanese light vehicles that often required careful handling and regular care, the American vehicle was built for hard use without losing basic function. Production conditions stayed tense because rubber and steel shortages forced engineers to review, even minor parts cutting everything that did not directly affect movement control and field repair. I note the unit costs was deliberately held within limits that allowed losses without strategic effect because the Army treated the vehicle as expendable but critical within the combat system. This changed employment logic because commanders stopped keeping transport in the rear and began using it at the front, accepting breakdown risk as part of tactics. Compared with British solutions where some light vehicles served narrow roles, the American approach aimed at universality, which reduced the number of vehicle types inside a unit. Combat pressure showed in the need to start after night cold, move on wrecked roads and operate without full maintenance for extended periods. I note that such use inevitably caused faster wear, but it was not treated as a flaw. It was treated as a fair price for continuous mobility and sustained operational tempo. In this context, industrial logic became an extension of tactical logic because each simplified component reduced reliance on complex logistics and long supply chains. That is how a vehicle emerged that did not chase perfection in peacetime terms, but matched war as it really was with its limits, losses, and constant time pressure. At this point, I turned to consequences when mass use began to reveal weak points, not in theory but in daily operations, where small design compromises accumulated into system problems during long campaigns. Practice showed suspension and drivetrain suffered first, because constant off-road movement with full load pushed beyond what even a simplified design could endure without regular mechanic work. Compared with German half-track solutions that carried load better but demanded complex service, the American approach traded longevity for rapid return to service. Combat pressure increased because repairs were often done at night or under shelling where speed mattered more than quality, and every mistake could mean losing mobility the next day. I record that the open-body vulnerability became clear under artillery fire and air attack, where the crew had little protection from fragments and secondary effects. This directly influenced tactics because soldiers began to use the vehicle more, cautiously changing routes and movement times to reduce personnel losses. Compared with British light armored carriers, added protection raised crew survival but reduced speed and versatility, which the US Army treated as critical. Cold and wet conditions exposed new issues when electrics and ignition became unstable, especially after nights outdoors without proper maintenance. The consequence was that some vehicles could not roll on time, forcing commanders to reallocate resources and change plans without preparation. Compared with Japanese vehicles designed for shorter distances and milder climates, the American vehicle worked at the edge of capability in environments it was not originally made for. I note these limits were not hidden but built into planning, where command expected vehicle losses as an inevitable part of long campaigns. Time pressure returned to the forefront because fast advances required using vehicles, even when partly faulty, if that allowed tasks to be completed on schedule. As a result, the practice of cannibalization appeared where several damaged vehicles were turned into one working vehicle, reducing total numbers but preserving the needed mobility level. This sharply contrasted with the German system, where more complex equipment often waited for full repair, losing time and creating gaps in movement. At this stage, it becomes clear the vehicle stops being mere transport and becomes a variable unit of war where value is measured not by lifespan but by tasks completed. The peak of conditions begins with night marshes, when limited visibility forced drivers to navigate by ground feel and engine sound, which became the only indicator that the machine could still keep going. Fog sharply reduced coordination between units, and the lack of a closed body increased psychological load on crews left exposed to cold moisture and the constant threat of sudden contact. Cold weather and rain changed vehicle behavior as lubricants. Thickened engine starts became harder, and any delay could break synchronization between infantry and rear elements. I record that in such conditions, the vehicle performed the least visible but most critical tasks, moving signal teams' orders and medical supplies that directly supported stability in combat. Compared with Soviet trucks with greater carrying capacity, the American vehicle compensated by reaching places larger vehicles could not reach. Time pressure increased because lack of communications forced reliance on physical delivery, and each run tested both the machine and human endurance. In night conditions, engine noise was both advantage and weakness because it helped crews monitor the vehicle but also revealed its presence in darkness. I note that commanders began to treat the loss of individual vehicles as an acceptable price for preserving operational tempo where stopping was more dangerous than risk. Comparison with French pre-war solutions shows that it focused on comfort and long life, lost meaning in a war where conditions change faster than equipment could age. The peak is reached in snow and ice, where limited traction forced slow movement, yet that reduced wear and improved the chance of reaching the destination. I see that survival in such conditions depended not on perfect design but on human ability to adapt and use the vehicle within real limits. The effects of that experience showed after the war when engineers studied not victories, but reports of wear repairs and losses under sustained load. The historical twist is that removal from service was not an admission of failure, but the result of a changing style of war with higher speeds, longer distances, and greater protection needs. Post-war documents showed the concept remained, but demanded a higher level of protection, comfort, and autonomy that the old platform could not provide. I stress that the solution did not vanish. It transformed and shaped both civilian and military vehicles of the next era. Service member assessments often came down to a simple conclusion that the vehicle did its job as long as it kept you moving forward without stopping, even if that meant constant repair. This confirms that in war equipment is judged not by years of service, but by the ability to support command decisions in real time. I close the analysis by returning to the opening thesis that mobility became the key factor that shaped success regardless of technological complexity. In the end, it becomes clear effectiveness was defined not by a single vehicle, but by a system where communications, logistics, and people worked as one whole. That is why in war, the decisive factors were not only weapons or armor, but the speed of decisions, the reliability of communications, and the people who could use limited tools under constant pressure.